Thank you to Steph Project for the invitation to be sharing some experience that I've been having in data visualization. I'm from informatics and communication department, and I had a master degree in multimedia, where I started to have some passion or some interest in the area of visualization, uh, interface design, and so on. And the today I will try to make overview of the main best practice in data visualization, and then we go to some practice. Okay, in the end of the session. Let's see if we have too much or too less time for that. Otherwise, we will practice, and of course, I will give the support later. So the first topic will be a briefly overview of data science and the part that will be focused on this session, data visualization. Then I'll talk some concepts about data visualization. Then we will focus on using Streamlit for creating dashboards and data visualization. The topics focus specifically on dashboards, some conclusions, reference, and web reference. So this will be for you study after the session. What is data science? So is according to Von Anderson, is an emerging field that uses combining algorithms and scientific methods to draw out knowledge and gain insights from structured and unstructured data. So data is the fuel of data science, but we need to use scientific methods like statistics, like mathematics, to transform the data in knowledge. So data scientist is a very broad professional. It requires business analyst knowledge, statistician, programmer. We need to code, yes. Database administration, to know SQL at least. Artificial intelligence, machine learning are very important to have insights of the data and more advanced knowledge. Transporter, data miner, project manager. So data scientist is a one in all area. We can divide in 5 different steps. So is called an OSEM model. We have the obtain, gather data from relevant sources. The second step is to scrub data in several formats. We can work on CSV formats that we're going to work today, but we can use databases, we can use big data structures with real-time data and so on. The E from explore, so find significance and trends using statistical methods. The next step is model, construct models to predict and forecast. Data science is not only prediction. We can apply methods for statistical analysis, but the most important area is, in fact, prediction. It's to use machine learning to predict data in the future and events in the future. And finally, interpret, that is put results into the good use. And this is the part of visualization. That's where we can show what we did in the previous steps. These are some of the skills that are required for the data scientists. This is the study from LinkedIn. Data institution, so you need to have a data-driven problem solver perspective. Data science needs to solve problems, of course. Text analytics and structured data to extract important insights. Okay. Multivariable calculus and linear algebra, statistics, they are all very important. Okay, that's why informatics, we say mathematics is very important. Mathematics is very important. We can say Jean Paul, it's very important, right? And statistics, of course, is a very important part of data science. Data preparation, converting raw data into different formats. Normally, we have to convert data. We need to do data cleaning. It's very important because data is not always ready for what you need to analyze. Data wrangling, that is unruly data that must process and make orderly and usable, and programming skills. Okay, these are the skills that most of the jobs from data scientists are required. Okay, we have also pattern recognition, machine learning, and deep learning. Okay, these are more from the informatics side, from computer science, and also software engineering. And finally, what is most important today is data visualization. Okay? It's the cherry on the top of the cake. So an approach used to present data in a graphical format to allow for easy analysis. According to Friendly, information, data visualization is information which has been abstracted in some schematic form, including attributes or variables for the units of information. So this is the concept of data visualization. It's used in a lot of areas: graphical design, interface design, so computer science, so arts. It's used in a lot of areas, and data science, of course, is a very important part of the process. So the goal of data visualization is to communicate data or information clearly and effectively to readers. How we can be good in this process to communicate, to transmit the message that you want to transmit to the user, to the readers. Okay? There are several ways to do that, to do data visualization. The first one is infographic. Okay, I'm going to show you some examples of creating infographic. The second one is charts. Okay, statistics, you know that charts are very important from, and mathematics, all the areas of mathematics, charts are very important. Diagrams, maps, okay. Reporting, forecasting, these are different types of organizing information, but they are very important. Marketing stories, faces to numbers, concepts, reinforced arguments, and dashboards. We'll focus today on the first four: infographic, chart, diagram, maps, and then in dashboards. Okay, dashboards, it will compile most of the previous one that we see. Of course, reporting is not the same approach as dashboards because reporting is historic data. Dashboards typically is real-time data. Okay? And forecasting stories. So infographics. I don't know if you can see that picture is difficult to read, but what is the most important in this case? Olivia Jones wants to thank what is the way that she managed her daily life, and the energy consumption and so on. And it's a infographics is a visual representation of information. Okay, it's designed to present quickly and clearly. Here we can see that we don't have a lot of text. We have small portions of text. So, what is the right information to transmit the ideas? We have graphics. Okay, most of them are done by graphics, but we have also bar score, where we can see the most important aspects of her life, like the device uses. Sorry, but it's difficult to read here. Average amount of the device that is used, daily activities, and so on. But as you can see, if you have all this information on the text format, nobody will read that. Okay. If you have infographics information, it's very appealing to know what is the most important information to transmit to the user. Okay, so this is one part. This is a good tip for your CV. You can organize your CV in a very infographic way, and normally the HR departments don't spend too much time reading only your CV pages. And one-page CV is the best CV that you can have. Okay. So all information you need to put in one page and take the attention from the HR department. Another example, chemical reactions. As you can see, we use a lot of color. Okay, color is important. Call attention, call for action, and we have circles to organize all the content, and it's more easy to relate the content. Okay. Another example. In this case, we are organizing in steps, so we have 5 different steps of the production design. Okay, we don't have too much text in each one, so it's a little chunk of text that will describe the most important part. But using icons, using a workflow, a step organizing the content, you get a better message to the user. So regarding charts, there are several types of charts. We have the bar chart that is the most common. So typically we start with this one because it's very flexible. We can use it in several ways. We have the line chart, the pie chart, the bubble chart, and the stacked bar. Okay. The difference between the bar and the stacked bar are in the same bar are different barriers. Okay. The tree maps. It's another type of data visualization. Word clouds, pictographs. Okay, pictographs, as you can see, it aggregates different types of information. Array charts, scatter plots that you draw plots in the XY axis, and multi-series. Okay. So normally in Excel you have all these types of charts you can choose, but you also have in the Python libraries, in the data visualization Python libraries that we're going to see next. So how to choose the best chart for the type of data? The first one, this is a very nice pictogram that I like to share always when we talk about graphics. The first one is to inform. So if you want to convey a single important data point, you see examples in the previous infographics. So use a single big number, okay, to reinforce numbers that are very important to transmit that information. Donut chart, single proportion, and a pictograph, okay, where you can have like population, parts of the population, so on. These are very good to inform. To compare, if you need to compare, okay, of course, bar chart is very for that, for categories, and you can have many. Here you have space to put many categories, normally in a row, but you can use it also in a column. Bubble chart, categories, few categories. Here you don't have many categories that you can show at the same time. Pie chart for composition. Stacked bar chart, we can use it also for comparing over time or across categories. Bubble cloud, composition across categories. Tree map across categories also, and word cloud, work frequencies. Okay. For instance, word cloud is very useful for real-time feedback. We use that several times on learning environments. Change. If you want to transmit change in the data, so we can use line chart, is the most used for that. We can use many series over time. Area chart, few series over time because it has several overlapping the area chart because it will draw all the difference between two lines. Okay. Timeline, if you want to distinguish events in time, and map chart one series by location. Okay. This map chart normally we use for geolocation when you have latitude and longitude data, so we use for that. And two more important categories. Organize. So if you want to organize categories like grouping, rankings, presence, we have lists. Okay, for process they are simple. Flowchart, process more complex. We can add more elements to the process. Venn diagram, okay. Man map, pyramid diagram, and the last one are tables. Okay. Of course, table is not the best way to present data. It's not so graphical. But if we use colors, if we use also backgrounds and so on, we can create more appealing representing that. Okay. And the last one is relationships. Okay, so we use relationship scatter plot, okay, histograms, and a series chart. So these are the three most important relationships diagrams or graphs that we can use. Okay, this pictogram is very useful when you have the data and you have to decide how we can present that data to the user. When you talk about diagrams, so the type of diagrams that we have, flowchart, okay, one example, mind maps, and then diagrams. Venn diagrams typically shows intersection between circles, okay? Tree diagrams and SWOT analysis. They are other type of diagrams. This projector has a low resolution. In my computer, I can see better than here. Other type of diagrams, for instance, fishbone diagram. Okay, another type. We're going to see an example. Next slide. Histograms. Histograms are bar chart, but they are in a different way. Wireframe, sitemap, and use case diagram. Okay. This type of diagrams is used in computer science, not in all the areas. For instance, wireframes is used in websites like sitemap, and use case diagrams is used for requirements in computer science or in software development. One example of diagram. This is the fishbone, as you can see. It has an aspect of the fish. It will focus on the problem, and you have all the parts of the problem, like material, measure, method, environment, machine, and employees. So you can organize all the key aspects of your problem in this fishbone diagram. The maps, of course, maps can be joined with Google Map or another cartography map. This example is electricity source in the United States. You can see the colors, okay, with the graph on the left. Then each consumption. In this case, the consumption is the photovoltaic, for instance, gas, oil, and so on. It's a very colorful map, but it has also information on the left that you can compare easily. Okay, any question? So these are the type of tools that we can use for data visualization. We have graphs, we have diagrams. When we talk about visualization, normally we have three types of visualization. The first one is InfoVis, is the information visualization. Okay. The second one is SciVis, is scientific visualization. They have different purposes. Okay. And different approaches. For instance, information visualization don't have the concern of be the right scale, the right data. Okay, it can be. You can think how we can transmit the information, how we can transmit the message. Okay. We can see that politicians use scientific visualization or information visualization. Information visualization. So they don't have the concern if the data or the message are accurate. They only want to achieve the goal, is the message that they want to transmit. For instance, scientists from physics, for instance, don't have the opportunity to do that, or it should not use that approach. It should transmit the right data, the accurate data. So we use scientific visualization for that. Scientific visualization, for instance, is used on medical image, okay, but is used also on ANSYS. Is one tool that can have all the thermic and the strengths of the metal, for instance. It's one type of scientific visualization. Finally, the GeoVis is geographical visualization. So it's all the visualization related to maps and geolocation. Okay. So these three types of visualization tools, we have different tools for different purposes. And the Python is a very rich ecosystem. So you can use a lot of different tools. For instance, information visualization, matplotlib is the most used. So it's a standard for that. You have all the graphs that we talked before. It's available on the matplotlib. Then you have Seaboard. It's like a wrapper that is easier and has prettier plots. Okay. It adds some details about graphical design of the graphs. Pandas is a wrapper for the data frame plotting. So Pandas is the most useful library for that. I don't know if in the last session you used Pandas. No. So Pandas is like a wrapper where you connect to the data source. You can connect to a CSV file, or you can connect to the database, or any data streaming connection, and then you can manipulate that data. You can filter, you can order, you can do some mathematical like total sums, and you can do some calculations that you usually do in a database. So you can use Pandas like SQL query language. Okay. Altair is another tool, simple to the graph, ggplot, Bouquet. The difference of Bouquet is the web interactivity that support really that effect. So you can use this library, for instance, to create a dashboard with data in real time, with data streaming. We have Shopify, Plotly. We're going to use Plotly also today. All of use HBplot, data shader. So these are examples that you can explore based on your requirements. There's not only one library that do everything we need, so we need to use several libraries for different purposes. In related to scientific visualization, we have BTK, that is a toolkit for computer graphics. You can use, for instance, for DICOM image, okay, from acquisition image, like with the image and so on. We have MyAvi for visualization interactivity. The difference from MyAvi and the BTK, we can have some interactivity like zooming, like filtering, and so on. And finally, preview. Regarding GeoVis, geographic visualization. Okay, these are the most important tools. We have Cartopy, Folium, again Plotly, so we can use Plotly for information visualization, also for geographic visualization, which is good. We have GMAP and IP lift. So all of them we can use like Google Earth engine. You can connect to Google Earth and add points. In this case, geographic coordinates to that map. Okay. So Until now, we know that graphics, diagrams are two important ways to represent data, but it's not enough to create a good data visualization strategy. Okay. What we need more than that is data story. We need storytelling to tell a story about our data. Okay, that's the last important thing about data. We can organize in three different aspects, like data. We need to highlight, so to have what is important from this data. Not everything is important, of course. Explain, so we need to explain that data. Okay. And we need to create visuals, okay, to highlight the data, but we need to engage with the narrative. Narrative is a story. We need to create a story with the data. So effective data stories can drive change, and we can get our goals with this strategy. I have here some best practice from that site to engage. It's a very good site for that. You have templates, you have all these best practices. It's like a community for data visualization professionals. Okay. The first one, tell a story with your data. So always remember to create infographics or any type of data representation, but always think how to tell a story. Okay? Beginning and the end. You need to tell a story step by step. Okay? That example is a data analysis. You have visuals that are processed. You have big numbers to show. Okay, and the most popular take out 5% of the content, and last one, your visual, narrative, and data. Okay, so very focused data to tell the story. The second one is choose the right charts and graphs for the job. Okay. It's something that we need to test. It's not even based on that guide that I previously present, that have for each type of information we want to present. It has several recommendations of graphics. Even using that guide, it's not easy to do that. So we need to experiment different graphics, different type of graphs, and we need to present to other persons and see what they understand from that data. Because this is like the programmer side. A programmer, when creates a program, thinks that it's easy to click on that button, to select that option box, and so on. And we think that is easy because we did that. Okay. But if we see the other side of the user, it's not so easy. So we have usability tests to verify that. So in data visualization, you need to do the same way. You need to do tests with the users and verify if the data that you are organizing, the graphs that you select, are well understood by the final users. Okay. Combine different types of data visualizations. Of course, it's not a good option to put all the graphs in the bar graphics, for instance, or all the graphs in pie chart. Choose the right graphics, but have some variation in index graphics. Here you can see that this is about work child labor, big numbers. In one line, how many children are employed before 70 years old. And a pictogram with the size, the proportion, okay, the pie chart, and we have here also pie charts with the different percentages. So color, we have big numbers, we have the right graphs to represent the data. Okay? Of course, if I put an histogram there, it can give me some information, but I have to take some time to look to the histogram and see the difference. Here, you can present all the important data to the user. Okay? Incorporate contextual clues. Here you can see that this is from a safari, and you have the animals, and you have if they are endangered or not endangered. The green is less concerned about, and you can see all in the map where the zone we are talking about, and the animals here connected with the color. Okay? The shape of the animal and the color, it represents that. So color and shape are important also to create a data story. The use of icons is the fifth best practice. Emphasize important points. Okay. We have the numbers organized as the most important data to transmit, and we can use icons for that. I leave here the links for algorithm icons, so you can use. They are free to use. So if you want to, for instance, IoT in factories, for instance, you can search all the icons that you need to represent that data, and then you can use big numbers like percentage, like overall numbers to represent that information. As you can see, when we use icons, we call attention from the user. Okay, the user will try to figure out what is this icon, associate that information easily. Okay. If you have plain text, it's difficult to memorize the data. Here, with infographics, is better. Use predictable patterns for layouts. For instance, if you look to this graph, it's very difficult to understand what is there. But if we have color to make some data context, okay, you see that in this case is the number, it's the name of the child's friends. Okay, Claire is 46% used. You can see that here on the bottom. Okay, but the others is very difficult to understand the evolution. This is along the years. Okay, of course, some years you have more children with that name, but it depends along the time. But this highlighting in color, you can have the pattern to the user to be easier to understand. Use bold fonts to make text information engaging. Here you can see that the numbers are bold, so it's the first thing we look at. Okay, and then we have complement information with a different size. So text is also a very important part of data visualization. I have two more tips. The other is use of colors, of course. It's not easy to, if we are not designers, to choose the best colors. Okay, but with the different tools that are online, for instance, colors.org, you can select one primary color, and it will give you a palette of the other colors that combine with that color. So it's easy to create this kind of combination of colors. Okay. And the last one is about fonts. So colors is important, but font is also important. As you can see, the Beatles, it's a logo that is a font. It was created only as a logo of the Beatles, and it's not used usually. So when you see the Beatles, you know that we are talking about the Beatles. Like Coca-Cola is another font that was created for a brand. Okay? So you have to use text carefully and intentionally, and the way that this is organized all in black, and the shadows of the members of the band, it has an intention to emphasize the story of the band. Okay. So how parts make up a whole? Okay, this is another tip for emphasize that. Here we can see that there are different percentages of components of the block, but all of them are organized to make a whole, so to be coherent in that part. Another tip: focus on the amazing statistics. So if you have a great number, you have to use that number as your advantage. In this case, 36% of the Great Lakes are on Canada. Okay, I don't know if Trump knows that, but okay, this is a big number. We can use it at our own benefit. Optimize your data visualization for mobile. Okay, this is important because nowadays most of the traffic, more than 80% of the traffic on the internet are on mobile phones. So if you create a very beautiful graph, but it's not possible to see on the mobile phone, you are not doing that good that data visualization. Okay. Strategically use size to visualize values. Okay, that here on this map we can see that the size is related to the cities in the United States. Okay, these are some of the tips that you can find on that vintage.com, but you also have the templates. Okay, if you go to this site, you can have free templates. Most of them are free, but some are paid. You can use infographics, so you can take some ideas, or you can use that template to create your data story and to present your data. So these are the best practice. Now you have the downsides. What is wrong? This one, what is wrong with this chart? Can you follow one line? No. Yes, everything is wrong because it's too much information. When you want to transmit too much information, it's not good. It's bad. So in the previous selecting graphs tips, it was said that line graphs can only be used for a small number of variables. So in this case, it was not possible. At least at 3, it's useful. More than that is not useful. So wrong chart type selection is a bad example. Failing to simplify complex data. What is wrong with this one?
Because there are some called the high hidden.
Yes.
There are loopers. Okay, they cannot tell what are the data, so it's not possible.
Occlusion. That's the main problem of this graphic. So
But
the bubbles. Yeah. But bubbles also is not useful in the too many variables.
specific in of when everything is seen.
Okay, again, it's important to show what you did to others and have their opinion. So you can test if your idea same way an interface when you are talking about data visualization is the same process. Okay. So in this case, you want to show too much information at the same time. Here we need to use different several graphs or different type of graphs. Negligent to tell a story. So here we are not trying to tell a story in this case. Okay. We only show numbers. It's important to have a process to show the information, highlight what is most important from that information. Another example, misleading pie chart. You looked at this pie chart. What is that? They are very near the categories. The colors, they are similar. So you will not give any information to the user. Okay. Another bad example, use of color. So here you see a palette of colors from red to orange, more or less, but don't has a mean of the color. Why we are using that? Okay. In this case, it will be better to have only one color because we see the size and the proportions of the graph, and color here is not adding anything to the graph. Okay. Inappropriate use of 3D. This 3D doesn't give any special information, so it could be a 2D graph. We should use 3D if you want to highlight some parts of that graph. And this one, this is very important. I see this several times, even in scientific papers, because Excel, when you select the data to create the graph, it will adjust the axis, in this case, the y-axis, and it will truncate. It will not start on zero. Okay, and so it's difficult to know the proportion between the columns. Okay, so remember that never truncate the y-axis because it will give a wrong perception of proportion.
Yeah. There are things, this is true. But we also need to couple with this. Okay. So it's not something that you see, okay, I understand. It's very romantic, but it doesn't see. It's from zero. I mean, algorithms and levels. It's 596 million. So we also need to take care that.
Yes, in the case, as general recommendation, we should always start on zero. Okay, but of course, there are some situations that cannot be, as we can see here, the difference between these two.
Yeah.
If we start on zero, it will be difficult to see the difference.
That's why the Excel doesn't.
And they clicked that file. But this is an example that we maybe we are not using the right graph for that. Okay. So we need to create a graph that is not sensitive to the scale of the, in this case, of the two data. Okay. Another example, using backgrounds. Okay. Normally, when we are trying to play around with data visualization, hey, this is a very nice background, and try everything. Okay, that's not a good option. This is, of course, about money, but don't need to use the background. In this case, coin. We can use backgrounds, but they need to have a meaningful and need to be clear for the reader, okay? Not only to use as a context. Another bad example. This is similar from the previous one, that is the misleading scale, okay? We can use that problem, we can have that problem in graphs, as we see before, but it could be in pictograms, okay? This is an example. Of course, the deck should not be bigger than the sheet if you want to use the right scale. And the last one, overlapping elements, okay? This is similar from the previous example that we have the 3D graph, that it's not possible to, there's any occlusion of data. Here we have also overlapping elements. If you use this type of graph, okay? So always try to use different graphics. Okay, you can do that on Python, or you can do that on Excel. And Excel is very easy. So you select data set, you select different graphics to see how it works. But you also can do on Python, on Jupyter Notebook, for instance, you can test all the possible graphs. Okay, it's not so easy as in Excel, because you need to use different variables from pandas, for instance, that will load from the x and the y axis. But it's necessary to do that. So you can test and avoid this type of occlusions, okay, or overlap. Okay. So, any question? Any point that you want to discuss before we move to Streamlit? No? Okay. So we have two data scientists that are not art adept, that are Python adept. They have normally two types of tools to visualize the results. Okay. One type is using Jupyter Notebook, so it's an interactive computing system. So you can add the Python comments, matplotlib, pandas, and so on. You see the results. Okay. What is the problem of that approach? It's not so easy to share the results. Okay? And it's good for research, for testing, for learning, okay? But it's not easy to share with others, for instance, with the business people, with the other professions that we need to transmit data, okay? So the other option is using a very simple framework to publish graphics, data graphics, and so on. Okay? One of the most simple is Streamlit. We can use the Streamlit not only for data visualization, but we can use to develop apps, web applications. Okay, we can do that, of course, in Python, and creating a front end in React using, for instance, Flask or Fast API. Okay, and we can create a front end in React or Flutter or another, but it will take a lot of time for that. You have to learn two different technologies. You have to communicate front end, back end, a lot of effort to develop a data visualization. So right now, data scientists are very welcome this technology, this tool, Streamlit, and normally they start to test and create models on Jupyter. But when they want to publish that models for a company, for other professionals, access this Streamlit is a very tool. Okay, so it's a fast way to make data apps. Okay, it's open source, which is good. We can build web applications to share analytical results, machine learning, and so on. So we can use all that we use on Jupyter or all the Python libraries we can use also on Streamlit. It's easier to create complex interactive experience. Okay, in Jupyter we cannot do that, so we need always to insert comments on the command line. Okay, and it's fast and flexible to develop applications, web application, and as I said, is a better alternative to Jupyter Notebook. So for what is the data scientist toolkit? So the first thing you need to have installed is Anaconda. Okay, of course you can have Miniconda and all the variations, but Anaconda is a full version. The free version, it's enough for what we need. Okay, we're going to use Visual Studio Code for creating the files, the Python files. And we can use also the terminal to create some comments. Okay. I recommend that you install Anaconda. What the Anaconda brings? It brings the toolbox and the cloud notebooks. It has Jupyter, so we can use Jupyter from here. It has the Jupyter one that is on the web, and it has installed Visual Studio Code. You can use any text editor for that, but Visual Studio Code you can run on the terminal commands. It's a better approach for that. Okay, open Anaconda Navigator and then run Visual Studio Code. So if it's not possible to launch from here, from the Anaconda Navigator, can you use Anaconda Navigator open? And you have all the applications. As you can see, some of them are installed and the other are launched. The one that is launching it means that it's already installed, and the others need to install. In my case, it was the option that I download from anaconda.org. It's free. Install it. Okay. So you can install it separately. The Visual Studio Code. It's only a text editor. Okay. And then we need to install the Streamlit. Okay. So you can select one folder to work. Okay. Here on the terminal, you have the terminal of Visual Studio Code. Pip install Streamlit. After that, you can type Streamlit hello. This is a hello world application from Streamlit. Okay. It has on the navbar, it has different types of demos that you can see. It's plotting this graph. It has the code, so you can use this code if you want to change or do something different. This is the base demo of Streamlit. So this is the first step to start to play with Streamlit. So to create the directory, we need to use the comment in the Windows Linux or did you change for that folder? So when you open, maybe you are on the root or something like that. So you need to create a new folder to work on the next examples. So we are now working only on terminal because we didn't create any Python file. Okay, for now we are here on the terminal, and then next we're going to create new files. You can create or you can open because I put on the shared folder the examples that I'm going to show to you. You don't need to copy from the slides. You can open that file that is on the shared folder. Okay. And then you execute here on the terminal your file. You're going to see that on the next example. Okay, so the next step is to create a new directory. You can do mkdir. I call it Streamlit apps. I create in my documents, for instance, and then I create inside that a new folder, plotting app. Okay, so this is the first example, is a plot demo.py. You can open this example. You go to Visual Studio and select File, Open File, and there's this file on the shared folder, one plot demo.py. So what we have here, we have import streamlit as st, of course, is necessary. We need to use that library. Then we have import time is only to use to compute time like dates and so on, time difference and so on. Import numpy as np. Numpy is a very important, like matplotlib. Numpy is another library that is very important to do some calculation mathematics. All that is related to mathematics, like average, sum, maximum, minimum, is on NumPy, so we can use it. Okay. It has more complex data computing functions. This is the most used. We have the progress bar. We have the ST sidebar. If you are using the left sidebar, we only need in Streamlit ST sidebar. In this case, progress, it will create automatically a progress bar. Okay, this is the beauty of Streamlit. You have a lot of components that are ready to use. You only need to invoke them. Okay, you don't need to have any concern about the organization because it's organized by standard with a left bar, nav bar that is top nav bar, and you have the content on the right. Okay. Here we're going to use the random here to create a random number. It will create a random number and we'll plot this as a line graph. Okay. The result, it will be something like this. Okay. You have the progress bar and you have the plot line number, okay, along the time. These are random numbers. So then we have the line chart here. Okay, this is the 4 cycles that will randomly generate numbers, and it will add to the rows of our. In this case, is an array of numbers. As you can see, it will start to add random numbers between 1 and 5. Okay, and it will add the axis. Okay, it will clean the progress bar, and it add a button. If you want to create a button, to put st.button in the name of the button. So if you open in Visual Studio this code, next you have to run. This is different from the previous. The previous is strictly hello. It's a demo. And this is to run our own files. So you could simply run one plot dem.py, okay, and it will start to run the program. Remember that to stop, you need to do Control+C. Otherwise, you cannot type on the terminal because it's running. The process is running. Okay. So after it's running, this screen. It opens on your browser. It will open on the localhost. It allows a port for running that, and it starts to plot. If you click rerun, it will change here the percentage of progress because it's a for cycle that will create random numbers and it will goes. Okay. So what are the libraries that we're going to use? NumPy, okay, as I say, is a powerful n-dimensional arrays. Okay, we have several numerical computing tools to manipulate the number. Pandas is the most important library for data scientists. It's your Swiss knife. You can use it for everything. You can use for data cleaning, ordering data. You can do some statistical on that. So it's a very good tool for data manipulation. Data frame we are using here is like a database. Each data frame is on memory data. You have calls, you have rows. Okay, like a database, like an Excel file, Excel worksheet. We can do that in memory, so it's very fast. We can connect to databases, SQL databases, NoSQL databases, or CSV files or XML files. Any data source can be connected to Pandas. And also, it's possible to connect to HDF5, that is a data streaming protocol that is very fast to transmit data in real time. Okay. Altair, we talk about Altair. It's a statistical visualization library. It creates very nice graphs. Matplotlib is the standard for creating graphs in Python. Okay. Seaborn, as I said, is a high level of Matplotlib. It has more beauty graphs than Matplotlib. Okay. And then we go to the second example. Here we're going to see in this example how to create a histogram, but using user input. Okay, this is a very short form using Jupyter. If you are using Jupyter, the data scientists need to change the parameters. Okay, here you can open, you can change that on selection box. As you can see, we don't have too much lines of code. Okay, this is the standard reports that we need to have at the beginning. This is the heads is our selection box, the first one. As you can see, is the number input. Automatically, it will create this box with only accept numbers. Okay, you use plus and minus to change the numbers, or you type only numbers. You can give the maximum and minimum value that is possible on that selection box. Okay, and then you have a text input. As you can see, it's number input, text input. This is 2 lines to create these 2 user interface boxes. Okay. And then we go to a random number. We are creating a binomial distribution number for creating histogram, the values of histogram. Okay. it will randomly create the values, and we create a list with our for cycle that we will add the random numbers to the histogram. And then to add to our figure, to our graph, we need to add the subplot comment for that. And then we have the title and call the pipeline. Again, to run this example, you need to put streamlit run to plot input demo.py. Okay. Every time you need to add another command, or you create a new terminal, or you do Control-C to stop, and then put run, streamlit run, and the name of the file. How to add text? In this example, if you want to add text, we have several ways to do that. In this case, it only has the graph, but if you want to add text, you can use the STWriter. Okay, it will add normal text, default font. We can format that with different size, but by default is 12 points Times New Roman. Okay, and then we have 4 different sizes. If you put ST title, it will create a big title with a font like 32 points. Okay, it will be like in HTML H1 size. If we select the header, it will be smaller. The markdown, it will be smaller, and the subheader, it will be smaller. So by default, it has 5 different sizes of text. Okay. Of course, we can format these like in HTML. We do it with the CSS, cascading style sheets. We can also do this here, but this is to be simple. This is to be useful for data scientists. So we don't have out of the box this kind of feature. So this is the simple formatting solution. The next example, we're going to use Penguin's data source. Okay. And this code, what has this code? We are reading a CSV file. Okay. And we are creating a graph of the Palmer's penguins. It has different types of penguins. The species Adélie, Chinstrap, and Gentoo. Okay, these are from the north, I think. So how the code is organized? So you can see here the title, Palmer penguins, the markdown with the size that is smaller. Okay, Palmer penguin bigger, and this one is smaller. And then we create our select box. This first select box is to select the variable that you want to use, like the bill length, bill depth, flipper length, or body mass. Okay, the bigger penguins, the smaller penguins, they have the bill bigger or smaller. And we can also add the x axis and y axis. Okay, we can use that on y or x. Okay. And then to read our CSV, okay, you should copy the CSV to the file, to the folder that you are working on. Otherwise, you need to add the path here for the CSV that you downloaded. Okay. If it is on the same folder, you can do it like this. You don't need to add the path. If we are on different folder, you need to add the path. Okay. So this will create. This is the pandas will create a data frame. And then we create our chart. Okay. As you can see, the chart is created using our chart. It means that is our it will use our CSV file. Okay. And then we add the X, I, and color. And finally add the chart. As you can see, we're using Alter. That's the library that we are using to draw this graph. Alter, it has a beautiful color graph. If you can use scatter, you can use this type in Matplotlib, but it will be very, very, as I said, this is almost the same thing than using R or Excel to create graph, right? It's not fully free. The free version has a lot of graphs, but if you want all the graphs, you have to pay a license for that. Okay, I think R is something like that. Okay. So our goal is to do this example, and you play with them to experiment and see the connection between the code and the visualization. Okay. But we have an exercise that is to create a dashboard. Create a dashboard using these examples. So you will need to see what the part of the code you need to from this example, from that example, and create a dashboard. We're going to use this data set for that. Okay, it's available on the folder. It's 3 CSV. It's trees of San Francisco. Okay, it has more than 10,000 entries, different trees. Okay. What are the type of Streamlit graphs? We have the line chart, bar chart, area chart, and map. Okay, we're going to use this different type of charts. We can also visualize the data on the table format. As you can see, this is only one line of code, and you get this table. And you can also filter the columns, order, and so on. So this is automatically created. You don't have to type all the code for that. What we're going to use is latitude and longitude, and this dBH variable. This is the size of the tree, the diameter of the tree. So the for example is San Francisco trees. It will create a map. We're gonna see the map. It will plot in all the latitude and longitude the map, and based on the size of the tree. It's bigger when it has bigger trees, and the smaller when it has smaller trees. So as you can see, that code only has 2 writes, title and regular text writing, and reading the CSV, and then we create our map here using the df drop NA and adding the sample. We filter for 100 points 1,000 points. We have 10,000. Of course, if you put 10,000, it's difficult to see the difference. So it's filtered for 1,000, but we can adjust to 100, for instance, if you want. Okay, and then the map it's created like this. Okay, as you can see, they are very simple comments. Okay, it's very easy to understand what is done in each comment, and with a few lines we get that map like that. You can zoom. Okay, you can drag and so on. Okay. The next example is using Plotly. Okay, we're gonna use Plotly to create the histogram, but we can also use it to create the pie chart. In the code that you don't have the pie chart, so you have to add this to your graph. Okay, you can open the file. The fifth file is a San Francisco trees Plotly. Okay, we're going to use the Plotly Express for that. As you can see here, we are creating a histogram. With 2 lines, we are creating the histogram. We only need to add the trees data frame. Okay, trees data frame. And the variable we want to use. We're going to use dBH, that is the size of the tree, the diameter of the trees. Okay. And Plotly chart. Okay, this is to create the histogram that we see, the second one. Okay. How to create a table? Which line of code is for that? To create that table. Yes, only this line. ST, because it's a streamline, right? And our data frame that is 3f.head. It will not show all the table, only the head, but you can, if you put 3df, it will create 10,000 lines. Okay, the head, it will only show the heads of the CSV and the first 5 columns. Sorry, the first 5 rows. Okay, now you have to add a pie chart. If we use, we're gonna use labels and values. Okay, that we only need these 2 variables for create a pie chart, and we're gonna use species and the width of the tree, dBH. Okay, for labels we're gonna use species, and for values we're gonna use the size of the tree, the width, dBH. Of course, if you don't filter that, you will have 10,000 different lines, and it's impossible to see a pie chart with that size. So what I did, I filtered for the first 20 items. So you put 0 to 20, and it will clip for the first 20 items of the data frame. Okay. And then you create a pie chart with a go figure, and the data, it will be the labels and the values, and then the Plotly chart. So this you have to type, or you copy from the slides. Maybe you have the access to the code in the slides. So we have 15 minutes left. We have to move on. Okay, this example is with Seaborn. It's another library. We can use Plot, we can use Seaborn, we can use both. They are different. The aspect of, for instance, the histogram, it will be nice here in Seaborn, so you have all the columns divided. The code is similar. Of course, it has different parameters, but with 3 lines, you can also create a histogram in Seaborn. So finally, we get to dashboards. What we see until now, you only have one column with a different graph. For instance, this one, you have one table and 2 different graphs. But what is a dashboard? Okay, and the dashboard is something that you organize the most important information that we need to take attention. Okay, in the car, if you are running the car without red lights or without orange lights, everything is okay. But if a red light pop-ups, it means that you need to stop, right? Or at least you have to shut down and restart your car. Our Polo from Stig, we do it several times and it works. But it's the concept of the dashboard. So it's a powerful way to present database intelligence. We can use data visualization techniques to display the relevant and actionable data. Okay. Track stats, and add key performance indicators, KPIs. Okay, this is very important for management. If we see if our company is running in the good way or not. Like Elon Musk, I see the dashboard of Elon Musk, everything is getting red. I don't know what happened. I didn't post nothing in the Twitter, in the X in the last 20 minutes. I don't know why my company is all on red. But it's that idea. So you have access to all the information that is necessary to run your business. Okay. We have these 4 steps. We have the define. So define the key metrics. The second one is to analyze. We need to perform exploratory data analysis. Have that also on the. It will be the next session. You will have that. Typically, is what I said. We should do this on Jupyter Notebook because it's easier to do that. You only need to insert the comments to visualize data and to process data. And then when you finish and you know what you want to show, you can go to Streamlit and create your dashboards. Okay. Then we have to build our dashboard. Streamlit is a nice tool for that, but there are other options. For instance, Power BI. We have. Quanto ajudam em OT? Eu esqueci o nome. Não, o visualização. Grafana. I forgot. You have Power BI, Grafana. There are tools that are specific, Tableau, specific for business intelligence for creating dashboards. Okay. Of course, Streamlit is not only for that, but we can use it for that, and it's easy to do that. And finally, to deploy. Okay. This is an example of a dashboard created in Streamlit. You can see that we can use the select box here on the navbar. Okay, we have maps, we have graphs, we have all the tables, we have all the information with a few lines of code to create a dashboard like this one. Okay. So the steps is first define the key metrics. Okay, well-defined metrics to measure what matters. Define the KPIs, key performance indicators. Insights that provide basis of the data-driven decision making. Okay. Example, how are sales teams performing? Or how is my campaign performing? How profitable is our business? So you need to make questions to your data. And the dashboard, it will give you answers for that data, okay? Second, perform exploratory data analysis. Of course, you will see this, what is exploratory data analysis in the next sessions, but is a solid understanding about the data that you have, okay? You have to do data cleaning, filtering, and so on, and to create, of course, graphs that will be used. We use pandas usually for that, prepare the data in pandas, and we can use visualize libraries like matplotlib, seaborn, or plotly. Okay. Step is to build the dashboard. So my recommendation is using Streamlit. Okay. Import libraries, page configuration, load data, add a sidebar, plot and chart types, app layout, and deploy in the app, the dashboard app. As you can see that example, we are organizing our content in columns. Okay, column 1, column 2, column 3. Until now, we are using only one column. Everything we add, it will be on the center in one column. To create a dashboard, we need to create these columns. The sidebar is automatically created. We only need to call sidebar, but the other columns we need to create it. It's not so difficult, okay? In Streamlit, what you need to do is like, I want 3 columns. You put column 1, column 2, column 3, and ST, Streamlit, columns 3. Okay? And then I'm going to add content to the first column. With column 1, everything here, it will appear on the left. Everything you put on column 2, it will appear on the middle, and everything you put on the column 3, it will appear on the right side. Okay? That's easy, like that. After this, if you add content here, it will be after the 3 columns. Okay? So you can create a grid of columns and lines. Okay. It's very simple. In HTML, it's more difficult if you want to organize the content in columns. The last step is to deploy your Streamlit app. Of course, you are now running in your computer, okay? It's not possible for others to share your graphs, your dashboard with the others. So you need to deploy your app in a cloud. This is the most simple way, using Streamlit Cloud, Community Cloud, okay? But you have also professional service using Snowflake, okay? This has authentication, okay? The Community Cloud, it's free. It has GitHub integration, but it's public. It means that you cannot protect your data. Okay? This is that. But you can use any other option like self-hosted. So we can self-host in a server in IPv for that, for instance, or using any cloud solution like AeroQ, Azure, Amazon, and so on. For instance, AeroQ, you can do it for free, so it has a limitation of access, but for most of the operations is enough, okay? Oh, 7 minutes to finish this dashboard. It's very easy. Create a dashboard of San Francisco trees with the follow layout. What is the layout? Is this one. So you have the sidebar, and then you have the data table, and you have 2 graphs. Okay, one graph on the left, that is the tree speed, and one graph on the side that is on the right, that is tree by age. Okay, this graph you already have it. Previous example by age. You need to compute by width. Okay. And here you have the by location that is already used. So what is expected here, you have to create how many columns? 2, 3. Two columns. Because this is a sidebar. This is okay, you use sidebar. Here you start to add the table as we do previously, because it will not have columns. Then you create 2 columns here. And you, with column 1, you put this graph. With column 2, you put this graph. And then out of the columns, you put another map. So you can do it now, or you can do it later as a homework. But it will be nice if you at least create the structure. You can use the code from the previous. You can put the same graph in both columns, left-hand side, and see that you understand how to organize the dashboard. So I hope you at least be more interested in Streamlit and the Seaborn and other tools for visualization. As a conclusion, data visualization is very important part of the data science. So if you don't have effective way to show your results, it will not sell. Okay, as you know, most of the big companies is 80 or 90% of marketing, and the other is innovation. Okay. So we need to have this kind of tools to improve digital transformation of the companies is very important. A lot of data is being produced in the company with the digitalization. So we need to transform this data for creating insights. Dashboards is a very effective way to have real-time data, to have insights about the evolution of the company. And the big data analytics, it will be very, very common in the next years. So big data, it means a lot amount of data to process. Streamlit and Pandas, they are good tools for that. And this is predicted AI, it will add $15.7 trillion by 2030. Okay, it will be a lot of opportunities. Now we have that the war machine, it will be one that will be growing the next year. The other, it will be AI. So data science, data visualization, it will be a key aspects in this future. Okay.